Welcome back, everyone. It's time for our third big idea 3C. This is rotations. Okay, so we're going to be doing the bulk of our work on page 12 and 13, but for now, I actually want us to go back to the warm-ups, and we're going to write down what we need to do for rotations. So this is 3C, rotations. Okay, for rotations, we need to do a few things. We need to be able to write the rule. We need to be able to actually rotate according to a rule. So you need to be able to read the rule. And then you need to be able to recognize the details of a rotation. Okay, got to be able to do those three things, all right? Write the rule, rotate according to the rule, and be able to recognize it. All right, let's get back to page 10, or page 12. Okay, so here is an example of a rotation. Notice that A, B, C, the same old triangle we translated and we reflected, has been rotated this way, okay? Now, there's a lot of details to this. Whenever we typically think about rotating an object ourselves, we think about rotating it at the center of the object. But there's no rule that says you have to rotate at the center. Here, we're rotating at a point outside the object called P. But a big deal here is that the center of rotation is very special, in that the point from the center of rotation to the starting point and to the resulting same point, like this to A and A prime, those are congruent because you're rotating around a circle. So that distance from the center of the circle to that same outside point should always be the same. It should always be like the radius of that circle. Okay? So those are always going to be the same. That's a very special property of rotations. In addition to that, whenever we rotate, the normal way that things rotate in life is actually counterclockwise. The only reason that we use clockwise rotations is because we live in the northern hemisphere, and shadows from the sun on old measurements that they would use for clocks, old sundials, would actually go from left to right. Sorry, not left to right. It would go clockwise. So the sun would be over here and would rotate this way from our perspective if we're in the center. But our shadows, because our shadows are opposite the sun, they would rotate this way. So clockwise is kind of the opposite direction of almost all rotations that we encounter. So our normal rotation is counterclockwise, and that's going to be our positive rotation. Clockwise will be a negative rotation. Now, in addition to having a center and a direction for our rotation, either positive, which is counterclockwise, or negative, which is clockwise, we also have to have a degree, which represents a distance. Now, right now in this class, we're only going to be rotating things most of the time in 90-degree increments. We'll do some others every once in a while, but for the most part, most of the time it'll be 90 degrees. Let's go ahead and see the rotation rule, though. Now, if you remember, in the last one, I used capital R for a reflection. We cannot use capital R this time, so instead we're going to use a lowercase r for a reflection. Okay, now, with our subscript, we're going to put parentheses around that. We're not putting coordinates, though, although it might look like coordinates. What we're going to do is we're going to put the degree of the rotation. In this case, it's x degrees. Then we put the center of the rotation. And as usual, we're going to put the input, A, B, C, and then the output. Equals A prime, B prime, C prime. Okay? And we could put a triangle in front of it if we wish, not necessary to do so. All right, so let's go ahead and see some more details of these rotations. Rotations are actually the hardest of the three transformations to do. Oftentimes people get tripped up about where the center is, about the degree distance, as well as the direction. So let's take a look at this rule. All right, this says rotate 90 degrees about the point O, which could also stand for origin, with our input of x and y. So if I've got this coordinates, it is at the coordinates 1, 2. If I'm going to rotate it 90 degrees, that is positive, so I'm going to go counterclockwise. And a good secret to rotations is this. If we start at quadrant 1, a 90-degree rotation in either direction is going to go one quadrant further. A 180-degree rotation is going to go 2 quadrants further. And a 270-degree, that's 90 plus 90 plus 90, is going to go 3 quadrants. If you go 360, that's 90, 90, 90, and another 90, you go right back to where you start. So we kind of stop at 360. But a rotation of 90 degrees will go just like this. There's a few other really cool properties with a 90-degree rotation. It creates a 90-degree angle right there. And let's take a look at the resulting coordinates. Resulting coordinates are -2, 1. Notice how the coordinates kind of switched places. One of them became negative. That tends to happen when we rotate around the center. Okay? Let's take a look at the second one. This is a 180-degree rotation. So, as I said before, if you start in quadrant 1, you're going to end 2 quadrants later. 1 quadrant, 2 quadrants. Okay, so this is quadrant 3. You go from 1 to 3. Now, this is actually a very useful tool. This allows us to use a center of rotation and rotate something 180 degrees. Oftentimes, if you want to build land across some sort of pond or something, or kind of put a new border across a pond or a lake, you would actually use this type of rotation to do so. Say this is the fence, have it end right there, and then you attach a string to it, and then you pull the string around so it goes across the river or the pond or anything like that, and you make sure it's at 180 degrees where you put the next post on the other side. It's a very useful tool. All right, let's take a look at the coordinates like we did last time. We start at 1, 2, and we end at -1, -2. Notice how both coordinates kind of switched signs. They were both positive, then they were negative. Here's our third one. We're going to rotate 270 degrees about the point O. So this one's going to go 3 quadrants, 1, 2, 3. Okay? And whenever it rotates, it starts in quadrant 1, goes to quadrant 4. And we could describe this rotation in one other way. I want you guys to see this. Rather than 270, I could put rotate -90 degrees about O. Okay? If I apply that to my x and y, it'll produce y, -x. They'll switch places, and the original y coordinate, not the original y coordinate, the original x coordinate, which is now in the y place, will become negative. So, this original one could be described in different ways, and actually with rotations, they could always be described different ways. So you want to kind of watch out for that. Is there an easier way to describe your rotation? All right, let's go ahead and try this out. What is a 90-degree rotation of A, B, C, D? Now, an easy way to do a rotation using a piece of paper on top of this is to take your paper, trace the object, and mark the center of rotation. Now, I like to mark the center of rotation like this. I put a dot and then a circle around it, okay? And that'll point out my center of rotation. Now, as you trace this in the center of rotation, the next thing that you're going to do is put your pencil right there. Hold your pencil down at that center of rotation, and then rotate the whole paper 90 degrees, or a quarter turn. That's another way to kind of think of it. 90 degrees is a quarter turn. 180 degrees is a half turn. 270 degrees is 3/4 of a turn. Or you could think of it as a turn backwards, a quarter turn backwards. Then a full rotation is 360 degrees. So whenever you rotate this object, you'll end up with the figure here. And I actually want you to see me trace the figure and see where it goes. This happened a lot the last time. See if that works. Yeah, it did. Okay, and note to self. In the future, do it that way. All right, so I'm going to take this figure and I'm going to rotate it. Now, the only hard part with rotating it on the iPad is sizes. See how it keeps on changing sizes on me and changing locations? That's just a little annoying, but it works out not too badly. This is almost perfect, but the size change made things a little bit off. D goes there, A goes there, B goes there, C goes there. And let's label it A prime, or D prime. Let's start with A. A prime, B prime, C prime, and D prime. Now, if you were wondering how I got that rule, I just read it right up here. And you'll notice it says, what is it? And I'm going to put at the end, equals A prime, B prime, C prime, D prime. There we go. All right. Now you can go on to the next page. We've got some more rotations for you to do. Here you've got a drum line. So we're going to go ahead and rotate the drum line. I'm going to write the rules first. So let's write the first rule. And by reading this, first drummer on a drum line is at the 20-yard line, and the sixth is at the 35-yard line. Ooh, that's important. Let me go ahead and draw the dots, and then we'll write the rule. So first drummer is at the 20-yard line, and the last drummer is at the 35-yard line. So 35 right here. And if you counted, there are 4 drummers in between in this drum line. All right, so they're all right there. Now, the drum line rotates counterclockwise 180 degrees. So we're going to go counterclockwise 180 degrees. Well, like I said, 180 degrees goes to the exact opposite side. And so I can just think about this and try to imagine this thing rotating around. It turns out that this 20 goes 15 this way, so it's going to be 15 on this side. It's going to be at the 50-yard line. Okay, get that bigger one. So it'll go here after that first rotation. Now, because I have kind of the names or the numbers for these, that's 1 prime, or that's 1, and this is 6. 6 was our center in the first place. So we rotated it 180 degrees, and these are the other drummers. This new place is called, not that, 1 prime. Okay, so I did my first rotation. Now let me write the rule for that first rotation. Number 1, we rotated 180 degrees, and it said counterclockwise, so we keep that positive, about the 6th drummer. Now, you could write the 6th drummer, or you could write the 35-yard line. I'm going to write the 35-yard line because that's what it says over here. Rotate about the 35-yard line. All right, and we're going to say rotate the drum line. And what does that produce? That produces the drum line prime. There we go. Now we're going to do our second rotation. We're going to rotate about the first drummer 135 degrees. Now, we've never done 135, but if you know anything about degrees, 135 is 45 past 90, or 45 less than 180. In other words, we're going to go almost a half a turn. Okay, and we're going to rotate around 1 prime. It'll end up right about there. Okay, and this is going to be where drummer 6 will end up. Now, let's go ahead and make some dots for the middle drummers. There we go. Now, they're all spread out a little bit more, so I think I got to bring them in a little bit. One, two, three, four. There we go. Now they're rotated 100. Oh, man. I keep doing that. 135 degrees. Clockwise. So I'm going to put a negative there to showcase that it was rotated clockwise. Now let's write that second rule. We rotate negative 135 degrees about the 50-yard line. And we rotate the drum line prime to produce the drum line double prime. Okay, so those are our two rules. And those are our transformations. Hopefully you have a pretty good understanding of a transformation and everything we've been doing. I hope to talk to you about this later.